All right, welcome to today's seminar. Good afternoon, everyone. I have the pleasure of introducing my good friend, Professor Guthrie, today. I met Spencer about, 10 years ago, I want to say, something like that, when I was attending a conference in Utah. And he gave me an excellent tour of downtown Salt Lake City. And also, I was very impressed by his research, but also his passion for undergraduate education and his hands-on project-based teaching style, which has raised my own standard for teaching since then. I don't know if you'll talk about that at all today at all, Spencer? A little?
Probably not.
Probably not. That's okay. But I'm so excited to have Professor Guthrie with us today. He has 25 years of research working with local, national, and international projects and agencies. His bachelor's degree is from Utah State University, and his master's and PhD are from Texas A&M. He is a professor at Brigham Young University in Utah. And he's going to talk to us about a cement treatment-based construction practice today. All right, with that, the floor is all yours, Spencer.
Okay, thank you, Samaya. I am at the vantage point where I cannot see any of the attendees. So maybe you could just tell me how many people are in the room and maybe a little bit about where y'all are from. Would that be okay?
Yeah, I don't know, because there's a camera in the front and it's pointing down. Typically, that would show you the audience. What is a good way of telling you? We have about, how many people would you guys say? There is 6 people in attendance, and I want to say about 20 people in the room, something like that.
Okay.
And we are a mix of, raise your hand if you're a master's student, please. Most of the room raise their hands. PhD students, about 1/3, so less than 10 PhD students. Raise your hand if you are in transportation policy, about 1/3 of the room. And
Okay.
the others, can you just shout out your area?
Environmental policy and management.
Can you hear that, Spencer?
Yes.
Okay. Shout out your area if you didn't raise your hand for transportation policy.
Also, EPM, environmental policy and management.
Okay.
Civil engineering, transportation,
Okay.
energy system.
Energy system, and I would say a few more on civil engineering transportation side. So you got a mix.
Okay. How many students would you say are focused on pavement engineering, the facility side? Anyone?
I see one of my students over there, Hagen, and myself, and then probably a couple of folks online.
Okay, wonderful. Thanks for helping me get acquainted with everyone. Just as a personal note, I grew up in South Texas, and my family had many children, but not a lot of dollars. And so early on, when I was perhaps between the ages of 10 and 12, my parents told me that I should plan to go to college, but I should plan to get good grades in order to earn scholarships, that they would not be able to help me at all with any of my education. I'm grateful for scholarships and the universities and the donors who provide them. And I'm also grateful to each of you for making the time to pursue additional studies. For me, my master's degree, Samaya, that's so good. I can see everyone now.
Perfect.
For me, the master's degree was probably the single most valuable year of my education, as I consider the impact on that it had on my current profession. As Samaya mentioned, I attended Utah State University, which was near my high school, and then discovering a love of concrete, I decided to pursue graduate school in materials and pavement engineering, and Texas A&M has a really great program back in my home state. And while there, I had an opportunity also to get to know my grandparents as an adult. Perhaps some of you, by raise of hands, still have grandparents alive. Several of you. That's wonderful. I miss my grandparents a lot. And it was while I was in graduate school that I was able to connect with them and get to know them as an adult. That was also a very rich part of my graduate school experience. And so Today, I'm excited to share with you at sort of a high level some of the specific details relating to pavement engineering, which is my passion. And if I click here, let's see if it will advance. Can you now see
Yes.
the first road trip across America? Okay, wonderful. PBS made a wonderful video documenting the work of Horatio Jackson in crossing the American continent from San Francisco to Manhattan in 63 days. And you can see seated beside him is a mechanic. In those days, the cars were not reliable, and as you can imagine, the roads did not exist. And so he took his mechanic, and along the way, I believe in Idaho, they also picked up a dog that you see right there in the middle. And the dog's name was Bud. And as it turns out, the roads were so rough in terms of their dust accumulation that Dr. Jackson purchased goggles for the dog so that he could be comfortable along the route. The PBS documentary shows that Horatio and his mechanic would often become stuck along the route and needed to rely on sometimes horse and buggy or train to bring parts for their vehicle. They also, when it would break down, they also would have a block and tackle or winch system that they had to use sometimes as often as every 30 to 45 minutes to get their car out of the mud. This was quite a challenge. And after they left, two other groups, hearing of their departure, attempted to beat them across the United States in this historic journey. But they were the first ones, and the car, as well as the goggles, are now on display in the Smithsonian Institute in the transportation exhibit for us to admire. And since that time, as cars have become more prevalent and the desire for travel, the need for travel became more prevalent, the field of pavement engineering developed in the United States. And of course, our goals are to provide a safe, smooth surface for the traveling public. It's also to provide adequate structural capacity using available materials and to resist deterioration due to traffic and environmental variables. Let's look at each of these for just a minute. Regarding the structural capacity, we typically specify various layer types of specified, even calculated thicknesses to ensure that each layer serves its intended function. Of course, we give a lot of attention to the asphalt or concrete at the top, don't we? We hear a lot about it. We see it as we drive. And the underlying natural subgrade is what Mother Nature provided us to build the road on. We have little control there. I'd like to point out today and emphasize the intermediate layer labeled as aggregate, the base material, often unseen and underappreciated. The base material not only protects the underlying subgrade, but also supports the overlying asphalt or concrete. How about materials? In Utah, we have an abundance of wonderful aggregates that are associated with the Wasatch Front and our mountain range. And sometimes we do have access to great aggregate supplies for our pavement engineering projects, but on other occasions, the materials are less quality. They may be recycled materials. They may have organics. Do you see the organics? Yes, 4 fingers right there on the little paw. So this is from an actual project that I was involved in here in Utah. And sometimes we need to use that local material. Where my grandparents lived in Louisiana, I believe that they had more alligators than they did aggregates. And in those places, sometimes they found that it was more cost effective to barge aggregate in from South America than to truck the aggregate in overland from West Texas, for example. So thinking about the available materials is very important in the design process. And that means that if we're using inferior materials, such as pictured, we need some way to improve it, some way to stabilize it, to improve its engineering properties. How about traffic? You're all, I suppose, familiar with the movies and TV shows from Herbie, right? Herbie and his friends out canvassing the neighborhoods and the cities. Sometimes we have just primarily vehicle traffic that's light. But on other occasions, we're needing to design roadways to carry sustained heavy trafficking. Until just recently, under our current administration, Utah had a good portion of its economy in coal. And so we have a lot of coal mines in our areas and a lot of coal trucks, and we have a lot of oil trucks that run through our streets. You might know or be interested to know that one pass of a fully loaded semi-truck, similar to what you see here, does about the same amount of damage to a roadway as between 5 and 10,000 passes of a typical passenger car, like Herbie. So traffic is another important consideration relating to the pavement engineering field. We also have environmental variables. In Texas, we had horrendous rainstorms that would come in and temporarily flood the streets, causing hydroplaning, as you can see in this picture, and very difficult transportation. We sometimes say, although we acknowledge that we need water to build roads and to properly compact base materials, for example, nonetheless, we sometimes say water is the enemy to our roadways. We like to keep it out. We want the roadways to be well drained with an appropriate cross slope and longitudinal slope. We need adequate drainage structures. And in some ways, pavement engineering then becomes a very multidisciplinary field that is quite exciting. Sometimes the water comes not as rain, but as snow, or in some cases, ice, right, with hail. And so here's a picture of our own interstate, I-15 in Utah. Snow plows in action, really quite an impressive scene. Because of the snow and ice and Utah's very clear bare pavement policy, we spend a lot of money clearing roads. In fact, in Utah, we have about 22 to 25 major storms per year, and we spend about $1 million per storm just clearing the roads. We will apply about 200 to 300 pounds of salt per lane mile per storm. And so this is a very significant part of what we do. The freezing weather, of course, also freezes the underlying materials, and sometimes that causes frost heave, a lifting of the pavement surface that causes roughness and sometimes requires a reduction in speeds. So regarding the pavement condition as a result of these variables, trafficking and water and freezing, we have some deterioration that might occur. Nationally, roads received a grade of D+ in the 2025 ASE Infrastructure Report Card, and some challenges come along with this, right? Funding for road reconstruction remains limited while costs are escalating. Traffic is increasing and drivers have high expectations for serviceability. We want to go where we want to go, when we want to go there, and we expect a smooth road. Pavement engineers and managers are therefore focusing increasingly on preservation of the existing roadways under the mantra that good roads cost less. In other words, spending $1 on maintenance now can save us $10 on reconstruction later. Maintaining roads in good condition also positively affects the economy. In fact, in some of our local cities, very strategic policies are made to maintain the most important roads, the commercial roads, the collectors, the arterials, in good condition, even at the expense of the residential roads, because we need to retain and attract businesses so that we can derive income from property tax and sales tax to continue to fund the roads. This leads to the important topic of pavement preservation. In other words, applying the right treatment to the right road at the right time. Earlier in my pavement design class this afternoon, I showed some pictures of, for example, an alligator cracked asphalt roadway. Can y'all envision that? Fatigue cracking, structural cracking all across an asphalt roadway. And the city, under very limited budget, could only apply crack seal one time after another to hold that road together. right? Ideally, we have crack seal applied early in the life of a pavement, and then as it progresses, we begin to use more invasive or more comprehensive repair services. The process of pavement preservation is really a strategic process that is intended to maximize the pavement service life with a minimum overall cost to the owner and hopefully to the traveling public as well. Eventually, however, despite our efforts to prolong that inevitable deterioration, all roads will need to be reconstructed. And a traditional reconstruction might look something like this. The asphalt is reached a terminal condition. And by the way, I'll pause for a minute to note that in the future, as y'all are interacting with especially members of the media, and you're referring to a roadway or a bridge or some other infrastructure, I recommend using the term terminal condition, not failed. The word failed sometimes incites emotion, right? And worry and panic. So you can just use the road has reached a terminal condition instead. So here we have such a road, and it's in a neighborhood. The excavation has occurred. We can now see the asphalt, the underlying base material, and in this case, the native subgrade, which was clay, very soft clay. And the objective here was to deepen the pavement structure by removing the upper courses, the asphalt and base, over excavating the subgrade, and then putting back in all of that pulverized material removed earlier, and then creating a new base material. So this is interruptive, very much so. Individuals who are coming home each night cannot park in their driveways. They cannot easily reach their own home. In some cases, public services cannot reach the neighborhood. Ambulances would not be able to reach the neighborhood. Garbage trucks cannot reach the neighborhood. In fact, contractors are often required to carry all of the garbage cans out to the end of the project. So these are policies, right, that we'd have to be concerned about. This is a difficult task. When the city in Provo, where I live, rebuilt, we had 6 weeks of this condition. In fact, the teenagers in my neighborhood decided to make signs. At that time, we were, as a country, operating, managing a war in Iraq. And our teenagers wrote big signs, "Welcome to Baghdad," they wrote, feeling that perhaps our road was like a bombed out roadway in a war-torn area. So this is difficult, right? There are real costs for our traveling public. And so with that motivation, I introduce a full depth reclamation process that can be very advantageous for many pavement projects. In fact, the process of FDR, full depth reclamation, with cement stabilization is becoming more appealing than a traditional reconstruction approach. FDR consists of the in situ pulverization of a typically failed asphalt layer with a portion, might be all, might just be a part of the underlying base to create a new base layer. FDR is most commonly used to rebuild structurally failed asphalt pavements, generally exhibiting at least 20% fatigue cracking or more than ½ inch of rutting. Under those criteria, a roadway might warrant some full depth reclamation consideration. It's both economically and environmentally friendly. Let's look at some of the benefits of full depth reclamation. First, conserves in-place materials. We reuse the materials on site. Mom and dad or grandpa and grandma paid for those materials, their taxpayer dollars, perhaps provided for the original construction of the road. And now we can reuse, repurpose, and improve those materials by leaving them right there on the same job site. Therefore, it requires little or no material hauling. And because we're not removing and bringing in new material, we reduce the loads on the adjacent streets. In so many instances, we provide a full depth traditional reconstruction at the expense of the surrounding streets, putting many heavier traffic loads than would have been needed if we had simply used FDR. It reduces construction traffic in neighborhoods which is improving safety, especially for pedestrians in school zones where children might be crossing frequently. It can also be used to maintain or improve the existing grade to address drainage problems that might exist. It saves cost by using that in-place investment. We already paid for it. We own it. Why not reuse it? We also save energy by reducing mining and hauls, reducing the use of the original material. And therefore, we say often that it's a very sustainable process. Those are some conceptual benefits. Let me show you some quantitative benefits. These come from the Portland Cement Association, and they compare 1 mile of a 24-foot wide 2-lane road with a 6-inch base. Full depth reclamation, shown in the yellow bars, and a traditional reconstruction, shown in the red bars. As you scan down the chart, you see that for full depth reclamation, we need far fewer trucks. We need far less new roadway material. We contribute far less material to the landfill, and we consume far less diesel fuel. So there are a lot of advantages from an energy perspective, from an overall environmental perspective, an economics perspective, to the use of full depth reclamation. But there are also some materials issues that we need to be aware of. And one of them is highlighted in this slide. What you see on the left-hand side is the California bearing ratio. This is a measure of the stiffness of the base material. On the x-axis, you see the RAP content. RAP, in this case, is not a reference to music. It is an acronym for reclaimed asphalt pavement. This is the pulverized asphalt that's mixed with the underlying base material. And in this case, I evaluated from 0% up to 100%. And you see that at 100% RAP, we have a relatively low CBR of around 22. Therefore, when we blend RAP with any base material, having a higher CBR, such as 30 or 64 in this picture, we inevitably reduce the CBR of the combined blend. And after blending with RAP, we may decide that this blend is no longer suitable from a structural perspective, and it needs some improvement in its structural capacity. And so at that point, we like to introduce the use of some stabilization. In this case, I'm going to talk about Portland cement, perhaps the most versatile, most common kind of cement, the same cement that would be used to make concrete. When we use cement, even in small concentrations, for example, 2% to 6% by weight of dry aggregate is really common. We get all of these benefits: increased rigidity for distributing loads, an almost entire elimination of rutting below the surface, reduced moisture and frost susceptibility, reduced fatigue cracking of the asphalt layer, and we can use a thinner pavement sections, which is frequently a solution when we have existing utilities that were constructed in a shallow manner. Perhaps many of you have been on jobs where especially a natural gas line was found by an excavator or a reclaimer machine, and now we have to stop all of our work, evacuate the neighborhood, call 911, right? That's not a happy day for the contractor. So there are a lot of benefits of using cement. Here's a schematic that shows the...
May I interrupt for a second?
Please.
I apologize. We forgot to establish our ground rules for asking questions. Is it okay if we make stop points and see if there are any questions?
Sure.
Is this a good time?
Absolutely. Anytime anybody has a question, just interrupt.
All right. Are there any questions on the background, on the method? What are you guys thinking? Here's a question.
I've done some cement stabilization before, but I've only heard of up to 4% addition of cement by weight of the aggregate. And I had you mention up to 6%. Could you tell us to what extent you can add what percentage of cement and avoid making the base of the road too rigid for the asphalt layer that's coming above it?
Looks
Yes,
like we
thank
got a
you.
super technical question, Spence. If you don't mind holding on to that one and going back to it, are there any more general questions about the method and all the background that Professor Guthrie really nicely laid out for us?
We will also have time at the end
All right.
for some more questions and discussion, should y'all be interested.
Sounds good. I just, sometimes a question gets in my head and then I can't let go and listen to the rest of it. I just want to make sure I don't have anyone like that right now.
Got it.
Dope. Do you want to answer that technical question now or later?
I will answer it along the way. It's an important question, and I think we can address it with some additional slides.
Perfect.
Is that okay?
Yeah.
Okay, fantastic.
Thank you.
You bet. Well, here is a schematic showing this full depth reclamation construction process. We start on the left-hand side with the original pavement. As I said, it might be considered failed under rutting or fatigue cracking, the common mechanisms that we see. We bring in a reclaimer, I'll show pictures in a moment, to pulverize the asphalt with all or a part of that underlying granular base material. And then if we're in a city, which is the focus of my presentation, and we have elevation constraints, for example, existing curb and gutter, existing driveways, then we may need to remove, as shown in step 3, a portion of that pulverized material. Alternatively, we could also just remove the asphalt layer and then cement treat the underlying base without adding any of the wrap. The fourth step shows stabilized base material now, perhaps with cement or another appropriate stabilization agent. And once that's been appropriately cured, then we can put a new surfacing, which might be either asphalt or concrete, or in some areas, in some places in the world, we might just put a double chip seal on top of the stabilized base material. And that's a far lower expense than placing a new HMA or Portland cement concrete. So let's look at the construction procedures. I'll step you through what this looks like on an actual project. Here we start with the failed pavement, or in other words, terminal condition, right? And you see plenty of fatigue cracking, we see some potholes, we see utility trenching, we see a variety of generations of patches, we see aging, it's gray. This road needs to be rebuilt. It's a local road here in Utah, and so it experiences cold weather as well that can affect its performance. And up to this point, I've primarily shown you pictures of FDR in conjunction with cement stabilization in very rural locations. Historically, that's where we have been able to use this technology. Today, I'm going to show you an approach that allows the use of FDR with cement stabilization in urban environments, where we often have higher ADTs, higher easels, the equivalent single axle loads, right, where we would benefit even more. So here's the failed pavement, and this is called a reclaimer, a large machine with a rotating drum between the front and rear axles that with a lot of horsepower can pulverize the asphalt and mix it with a portion of the underlying base material. After the material has been pulverized, we can reshape it. If we don't have access to a large machine, we can also use a smaller asphalt zipper. Perhaps some of you have seen these on job sites. It attaches to the front bucket of a loader and is owned by a lot of cities. They can use this for not only utility trenching, but for full depth reclamation as well. The net result is that we have a new base material available to reshape. And once the material is moved around and reshaped, we can restore a crown on the road, often looking in Utah for a minimum of 3% slope. And we can add more material if we find that we're short, right? Constitute even with more aggregate. And after the reshaping, it's time to spread the cement on a cement treated job. So I want to pause and make a note that historically, the cement is applied as a dry powder. On the left-hand side, you see the truck, a distributor truck, that uses pneumatic pressure to blow the dry cement powder out of the distribution nozzles on the back of the truck to apply it to the grade. And even though we've been talking about only 2 to 6% cement, that's all we need, you can see that the thin layer of cement generates quite a lot of dust. And if I remember right, it was about 2019 that OSHA, the Occupational Safety and Health Association or organization, implemented and enforced a new regulation governing exposure of humans to silica dust. Portland cement contains a lot of silica, and it's a respirable human hazard. And it's for that reason that we simply cannot use this process in urban environments. We can't have that dust on our vegetable gardens in neighborhoods. We can't have it collecting on families' cars or their front porches. We can't have it even breathed in by our construction crews. So you have to be really careful with powder. And on the right-hand side, you see a little adaptation made to a distributor truck where we put a skirt around the back of the truck to try to contain the dust. Well, that's suitable and can improve the reduction in dust during the application, but it does not handle subsequent sources of wind or adjacent traffic. Let me show you a project that I was on this summer. This is a project where the cement powder was placed in dry form in the right lane. Do y'all see that? And because it's only a 2-lane road, we have to maintain traffic live in the other lane using a one-way flagging operation. And I'm parked waiting for my turn to drive down the corridor, right, to go do pavement testing. And here comes a line of semi-trucks. And you know what I tell my students? Start rolling up the windows. Everybody get the windows up, right? Because you see what's coming. The trucks, even though the powder is already on the ground, there's enough wind velocity that picks up the powder and just blows it off. There were portions of this pavement where the cement had been placed just hours earlier, but you wouldn't have known. It was all blown away. So this is a significant problem. Look what it turned into after this truck passed. Almost a complete gray out. And if this is a project where you have two-way traffic, this is a safety issue because we have traffic visibility problems. There are some places like Wyoming where I've worked where the wind blows 30 to 50 miles per hour in the afternoons during the summer, and it just takes all the cement right off the road. This is an opportunity for innovation, isn't it? When we reach a point like this where we're trying to use good technology, proven cement technology to improve urban roads, we have to think of a different way to do it. And I was very grateful several years ago to work on this project with a Salt Lake City Corporation engineer who was working in a space where he could take risks. He could try new approaches without fear of retribution. And he was smart. We decided to do some of these new efforts that we were investigating on residential roads where we wouldn't have a high risk. And what we invented was a means of applying the cement to the pavement with an absolute total elimination of cement dust. How did we do it? First of all, we involved our very reliable ready-mix concrete industry. We have a great relationship with the concrete industry. And because a local ready-mix concrete plant is close to almost every urban road, we can have them bring cement to our job site. No problem. Then, to get a nice even distribution of the cement, we invented the slurry spreader. The slurry, a mixture of the cement and water, flows right through the cement or the concrete chute into the spreader basin and then exits those 6 nozzles that you see. And it can be readily applied in an even, uniform fashion, even in a residential neighborhood. So you see that nice green lawn of the home across the street. You see a worker just very casually walking along the truck. We're not worried about dust at all in this case. We've eliminated the possibility of wind blowing it away. We've eliminated the possibility of respirable hazards. We've eliminated the possibility that the cement dust might settle on someone's personal property. And we've engaged the ready-mix concrete truck drivers who are very often in the later parts of the day, once the major concrete placements have been done, are available, right? We have infrastructure, the ready-mix concrete trucks and plants available to help us with this project. And I also want to point out one more thing. This is related to concrete technology, where we have an advantage using slurry compared to Portland cement powder beyond what I've already described. Do you know that we can add hydration stabilizer, sometimes referred to as set retarder, to a concrete or to a slurry to slow it down? So even though it's in contact with water and the cement is hydrating, we put in a chemical at the batch plant that cannot be added to dry powder, and we can give our construction crews another 2 to 4 hours of time to mix the cement slurry, to work it, shape it, and compact it. This is pretty phenomenal, especially in places like Utah where we have a limited construction season. We can't rebuild our roads during the winter. It's too cold. Can't compact the asphalt. It cools too quickly. And so we're in a hurry during the summertime, and we like to get as much done as we can, even in the heat of the day. So at the top, to the gentleman's question in the back, the cement concentration is determined through laboratory testing. That would be the subject of an entirely different presentation, the tests that we can consider. Different base materials may contain different amounts of clay, for example, which is often the bad actor. We say a little clay goes a long way, fun little rhyme, right? And we need to stabilize it. We're normally looking for a certain minimum strength, but we need strength today, we need strength tomorrow, we need strength in 20 years, we need strength even in 40 years. Some of these pavements will last for 40 years. Indeed, I'll mention, Samaya will be especially appreciate this. Salt Lake City has some pavements, concrete pavements, that are now more than 100 years old. So it's phenomenal. When the roads are built right, as long as we've taken care of those underlying utilities, we may not have to touch the road again for a long time. So based on the laboratory testing, we might recommend 2 to 4 to 6%. That's common. The most cement that we can reasonably apply and mix in on a job site using this process would be about 12. And that would require 2 passes, each at 6%. After that, it's just too much cement. We should consider some other options like over excavating the site, replacing the material with better material, etc., just from an economics point of view. Okay, so once the truck shows up, we have marked out the area over which the truck should be unloaded. And so we have a person on the ground who is directing the truck driver. Remember that the truck driver can swing their chute left and right. They can move forward and backward. They can increase the speed of their drum to increase the rate of delivery of the cement slurry. And if for some reason we have a new driver, some of them are only in the industry for a month when they're assigned to one of my jobs, and they still figure it out fine. And if for some reason they put down a little too much, then we have a grader operator who can just come on over and blade some of that extra slurry off of the high spot onto the spot where it belongs. So we have an orange line. Do you see that across the grade? Just marking the perimeter. We're going to unload this truck onto the grade. And as soon as we start unloading, you see the operation continuing in the far left, then the reclaimer can come on and begin mixing. Generally speaking, unless we've added a hydration stabilizer, as I mentioned earlier, we try to get the cement incorporated, mixed in to that pulverized material, normally within 2 hours. We need to do that quickly because otherwise the cement will begin setting, and then we will not achieve the proper compaction and grading that we want. So here's a picture. Again, no cement dust at all in a neighborhood, and we're strengthening significantly this layer with some cement. After that, we have compaction. Sometimes we see pad foot rollers, other times we see only smooth drum rollers, but the last roller to touch the road should be a smooth drum. It leaves a nice smooth surface. It can crown the road just right, and this provides the appropriate compaction. I've got a note at the top. Compaction specs are determined through lab testing. Of course, we determine the maximum dry density, and then we often use nuclear density gauges to measure density very soon after compaction. And we can also measure stiffness. There are a lot of ways to assure the quality of this compacted, cement-treated, reclaimed layer. The next step would be final grading. So at this point, our efforts are to ensure that we have a good cross slope, good longitudinal slope, enough space against the lip of the gutter, left and right, to ensure that we have room for the appropriate asphalt or concrete thickness, and make sure it's done, graded, in other words, before the cement begins really setting up. Okay, after the grading is finished, it's time to cure it. Just like we cure concrete, we cure a cement-treated base. Our intent isn't so much to add water to the layer, it's to prevent the water that's already there from evaporating. That's the same concept that we use for concrete. When we put concrete cylinders that we've cast in the laboratory into a fog room, we're just surrounding the cylinders with 100% humidity to prevent evaporation. Well, here, out exposed to the wind and the hot air, evaporation is constantly happening. And so we have to restore the water by bringing a water truck. Sometimes in Utah, where the measured relative humidity can be as low as 6%, and the wind picks up at night as the air is moving down from the canyons into our lower land, we might have to do this many times through the night just to keep it wet. There are alternatives. We realize we're also a desert environment and we don't like to use a lot of extra water. So if we need to, we can also just simply apply a prime coat, a bituminous seal coat, to the top of the cement treated base. And then we don't have to keep watering it, so to speak. So here at this point, we're curing. And during this process, notice that we never did dig out all of the material. The residents can come home to their driveways, park in their driveways. The garbage truck can get in and out. If there were an emergency, an ambulance could come. We don't have to worry about some of those concerns. So very minimal disruption to our neighborhoods, to our communities. Now, just like concrete, cement treated base also shrinks a very tiny amount when it cures. To accommodate shrinkage in concrete, think about sidewalks, we deliberately install joints. We perforate the concrete, if you will, forcing it to crack at specific locations with a more desirable geometry so that they're straight cracks, right, and they're easier to maintain. We don't do that for cement treated base. And if we don't intervene, it will crack on its own approximately 15 to 30 feet down the road. And those cracks will often reflect into the asphalt. I'll show you a picture. So when I was at Texas A&M, where we use a lot of cement treatment and lime treatment and had a lot of this cracking problem, we had to figure out a way to stop it. And so my research group designed an experiment where we introduced a new technique to the industry called microcracking. You might also see it in our early publications called pre-cracking. But the idea is that just 2 or 3 or maybe 4 days after construction, during the curing process, we bring the same smooth drum roller to the job site, and now we turn on the amplitude of vibration, so it's maximum, and we have the roller operator drive up and down the grade several times where we're monitoring the stiffness after each pass, and we are cracking deliberately the full depth of the cement treated layer. In other words, when we're finished, we have a series of very fine cracks that look something like this that allow for the shrinkage to occur, the total shrinkage, over all of these hundreds or thousands of tiny cracks, such that no crack ever develops a sufficient width to propagate into the overlying asphalt. This technique is not needed if concrete placement occurs, but for asphalt, we microcrack it. The idea is that after we've finished the microcracking, the base material might have a reduction in overall stiffness of 50%. But remember, the cement is not finished curing, and it will continue providing strength gain, and such that by the end of 7 days, we normally see a complete restoration of the original strength, and it will continue gaining strength after that. So that's the microcracking procedure, and this is what you get if you don't microcrack. I worked in the flexible pavements division at Texas Transportation Institute, and my supervisor was Tom Scullion, who provided that picture. Not pretty, structurally sound, yes, but there's some roughness here that we would like to avoid, and some maintenance issues, the crack seal, we'd like to avoid when we over-stabilize and cause the shrinkage cracking. Okay, we're now ready after microcracking for surfacing, and that can be a new asphalt layer, or it can be a new concrete layer. What I do want to emphasize, though, regarding policy on this matter, is that before we start any of this process, we need to be thinking about the underground utilities, don't we? When I first moved to Utah and I purchased a home where I live now, I observed that the Utah Department of Transportation arranged for a contractor to come place a brand new, beautiful asphalt overlay along one of our major principal arterials. And then, to my astonishment, just 1 month later, the water department installed a new water line. So for those of you in transportation policy, I beg you, right, ensure that we have good communication between divisions in municipalities and departments of transportation so that we don't end up with such a disaster, I'll say, where we've just cut into a brand new asphalt overlay. All right, here's my concluding slide that I would like to share today. Full depth reclamation in conjunction with cement stabilization can be a very effective method for reconstructing failed flexible pavements. And in particular, cement slurry can be utilized in urban areas with absolutely no fugitive cement dust. It can be applied using a ready-mix concrete truck, which is available almost anywhere, and equipped with a slurry spreader. And we have been using this method now in Utah for more than 10 years. Many cities now own roads that are constructed using this technique. There are new projects always on the horizon. It's a really great technique for saving money on the side of the owner and saving money on the side of the traveling public. So thank you very much for your attention. I do hope that we can have some discussion and let me answer some of the questions that you might have.
Thank you. Questions?
Is FDR more brittle to tensions? Because when I think of cement, it reminds me of concrete, and concrete is weak to tensile forces.
That's right. Cement treated base is no different. It has a lower tensile strength than compressive strength. And there are pavement design techniques to ensure that the thickness of the cement treated base layer is such that we do not have fatigue cracking of the actual cement treated base layer under the asphalt. And that would again be the subject of another presentation, right? We cover that in my pavement design class. So it's an important recognition. Stiffer layers need to have fatigue cracking as a consideration, a criterion in the design process. Thank you.
Sir, how did you apply the microcracking? Was it by the run of the roller?
Yes, as we go back to the picture, I normally recommend a minimum 12-ton roller. Generally, it's the same roller that was used for compaction, and we'll have them do a number of passes over a short distance to establish a roller pattern. We're typically looking between 3 and 5 passes of the roller, sometimes as few as 2, to establish that cracking pattern that we're looking for. The vibrator is on full amplitude, so this is bouncing. to induce a lot of energy into that cement treated base. And we just walk it along, kind of a fast walking speed until we've achieved the cracking pattern. Then we stop. Very important to stop before we go too far or we damage the cement treated base.
Thank you. Where are the pavement students? I see you guys back there. Any questions? All right, we're not getting any.
That's okay.
Anyone else? Going one?
I have one.
Oh, go ahead. We'll go here first.
I guess I had questions regarding, because it sounds like public roads for maintenance over a long period of time and like rethinking or thinking through more feasible and environmentally friendly options to maintain those roads. But in terms of like new development, particularly like in the home building sector, I know the developers have to like build those streets out and then dedicate those roads to the city or jurisdiction. And so I'm wondering from that perspective, like, are like engineers within that sector thinking through about the type of like materials that are, you know, feasible, cost friendly? Does that make sense? Like, are they kind of thinking through the
Yeah, thanks for your question. I understand. When we're talking about new development, we're often talking about developers who are developing the land, like you said, and that land may be already part of a city or maybe it will be annexed by a city in the future. The developer will often not retain ownership like an HOA or a homeowners association would. And so they have inherently a motivation to provide a bare minimum pavement structure at the least cost. So they will very carefully examine what is the standard section for this class of road, a residential or local road, and they build the bare minimum to that standard. That's my experience. On the other hand, if it's an HOA and they intend to retain ownership of the facilities, they're often motivated to look at the innovation to try to figure out how to minimize their long-term costs, even with greater upfront costs. And that's when we sometimes see concrete pavement in HOAs or these cement treated base technologies. I will note, I'm aware of in Colorado Springs, Colorado, we have some developers there who have very well developed this technique. And even though they are not building HOAs per se, they are using cement treated base in all of their developments because they have found that if they don't use cement treatment or they get some rain during construction, their access to their own home sites becomes limited. They're stuck in the mud, just like Horatio Jackson in that early trip across America. And they love the waterproofness of cement treated base. They can drive on it even if it's wet. And so they've gone to it because they see a win-win. It's better for the city once the city owns it, and it's better for them right now during construction.
Thank you.
There are some developers, right, who are using it. It's an opportunity still coming to be developed. Was there another question also?
Yes.
Yeah, I have three questions. One, could you clarify why you said you advise microcracking for asphalt concrete surfacing and not typically just a concrete surfacing at the very top? And then the second question is, would you recommend pulverizing a previously cement treated base as well? And how easy is that? And last question is, since recommending microcracking, how has the cost of reconstruction gone up, especially from contractors that have implemented this method?
Okay, those are great questions. Thank you. First of all, regarding microcracking, what we find is that in general, asphalt pavements are thinner than concrete pavements for residential roads in particular. As we move to higher trafficked roads, the thicknesses approach being similar. But we also know that the concrete has a stiffness, a Young's modulus, of around 4 million psi, whereas asphalt is around 400,000. So concrete is 10 times stiffer. Being generally thicker and stiffer, we have not yet documented the occurrence of reflection cracking from an underlying cement-treated base in a concrete surface layer, whereas we frequently see it in asphalt. So the absence of the occurrence of the reflection cracking leads us to have this policy where we can omit micro cracking when concrete pavement will be placed. Is that okay for that question?
Yeah.
Okay. The next one would be an interesting one, right? What if we had built a cement treated base layer, maybe put an asphalt surface course on it, and then later choose to rebuild the road again? This has happened. One of our interstates in Utah was built with a cement treated base course, and it was when the new, what we would say, 2000X in those days, new software had come out, the now Darwin ME software, and some of our engineers at the DOT decided that they would try it out, and it rewarded the pavement design with a thinner asphalt if you made it stiff. And they put a 5-inch thick, very stiff asphalt on a cement treated base on one of our interstates. Now, some of us might say, wow, that's like putting a mirror on a bed, maybe a stiff bed, but it's nonetheless a mirror on a bed. And sure enough, within 4 years, the asphalt was completely cracked. It was just too stiff. It was no longer really a flexible pavement as it should have been, and it was too thin. And so we had to rebuild that. The reclaimer came in to try to pulverize the cement treated base, and they had some difficulty. In some cases, some of the teeth on the reclaimer drum sheared off. But in general, they were able to remove the cement treated base material. My argument to them was, why do we have to remove it? It's already cured and established. Why not we just remove the asphalt? Well, there was a little issue. And the issue was they needed to put thicker asphalt on, right? They had put too thin, the mirror on a bed. They needed to thicken it. And if they thickened it to the proper depth, they were going to have to put in guardrail along a long distance of the interstate because there was a drop off. And it was right on the level of being okay, but any thicker would produce a deeper drop off and they'd have to put in a guardrail. And so they decided it would be cheaper to just remove a portion of the cement treated base and avoid putting in the guardrail. So they succeeded in doing it, but they did have to replace some extra teeth on the reclaimer. Okay, is that okay for that question?
Yeah.
Okay, and then the last one was relating to cost. That's always an important question because we have limited budgets, and a lot of our budgets come from taxpayers. And we're accountable to our taxpayers. We need to ensure that we are responsible with their funds and using the funds with the maximum benefit. So to give you some idea of pricing, the lowest price per square yard for a cement treated base on a rural job that I've ever seen is around $5.50 a square yard. That's pretty low price. What we normally see is probably on the order of $8 to $9 or $10 a square yard. That would include the cement, all of the prep, the application, the curing, everything. In the job where I showed you the traditional reconstruction, where they over excavate the subgrade, they were getting that done for around $12 a square yard. Traditional reconstruction in Utah, including all of the steps and all of the layers for a similar road, would be right around $30. So we have about 50% savings that we can generally safely say if this full depth reclamation process is used.
Hi, may I follow up on the cost question? I was just curious how, when this has been implemented, it's helped the state sort of address their asset management plans and then sort of how they look at life cycle costs. So not just obviously construction, but for downstream asset management.
Yeah, that's a great question. I'll note that the Federal Highway Administration, which often is a guide that or reference to which state DOTs refer, in their little toolbox that summarizes the available treatments for asphalt roadways in particular, they actually omit full depth reclamation. I don't know if that was a political decision by someone, but it's omitted in the Federal Highway Administration document. And therefore, state DOTs need to be looking for this kind of technology and implementing it proactively on their own. It's not something that the FHWA I'm currently seeing is pitching, right? But the state DOT definitely has bought into it. They see the value of it. And the way that starts is with education. So when I first came to Utah, I brought this technology with me from Texas when I was there at Texas A&M. And I gave presentations, right, looking for opportunities at our state level conventions, our industry association meetings to talk about it. And then pretty soon the state DOT started calling and asking questions, and we did some trial studies and developed the mixed design criteria. And now it's part of their regular toolbox. Most of our pavement engineers in Utah are familiar with it. They know how to determine when a pavement is a good candidate for it. They have an idea about how to construct it. Our contractors are well trained. In some cases, I'll do seminars for our contractors so that they can minimize the risks that they might otherwise feel accepting for the first time or bidding for the first time on a cement treated base job. But it's now one of our pavement preservation toolbox tools, right, here in Utah. And if the cement treated base is built correctly, I dare say that a pavement engineer would only need to go to that road one time and they would retire, right? They'd finish their career before that road would ever have to be rebuilt. There might be some mill and fill, sure, if it's an asphalt roadway, some proper pavement preservation, but a full reconstruct would not be needed. Yeah, great question. We always have to be looking at the big picture. How does this technology benefit us in the overall strategy, right? I love that question.
I like that. That's one way to look at LCCA, Spencer. Build it so you don't have to go back until you retire. This does not apply to senior engineers.
Yeah, that's right. Please, in the back.
Oh, I have a question related to the sidewalk because I'm doing like a street redesign project, and I find the sidewalk pavement is generally like damaged by the tree roots, and so there's some drainage problem. What materials can like help reduce this issue, and does the micro cracking can help?
With sidewalks?
Yeah, sidewalks. Yeah.
Okay, this is an interesting question. In general, for sidewalks, I have only seen cement treated base used during construction for temporary walkways for pedestrians. I haven't seen contractors or owners implement cement treated base under pedestrian facilities where we would expect hopefully to have lighter loads. It's not to say that there still wouldn't be a benefit though. So I'll share two experiences. One in Texas, right? Construction project on the Texas A&M campus. It was a long-term project. We have a lot of rain there. And when it rains cats and dogs, as we say. The sky just opens. And to prevent all of the many thousands of students from stepping in the mud, contractor just built a really nice temporary cement treated base walkway. And it served for months during construction, despite all the rain. That was a great application. It was removed after they didn't need it anymore. Now, go much farther north to Alaska. I do a lot of cold regions engineering, and I was visiting my friends at University of Alaska, Anchorage, and walking along some of the trails that connect their buildings. The trails are all asphalt, and they are widely cracked right down the middle, because during the frost heave mechanism, as the center of the trail is being lifted, this is like a 6-foot wide walking trail, as it lifts, it splits the asphalt trail right down the middle. The underlying soils are frost susceptible. They wick water. The water is present and they have winter. It's the 3 W's, right? Water, winter, and wicking. We can't do much about winter in Alaska, and really hard to control water too, but we can change the soil so it doesn't wick. That would be another good implementation of cement treatment on a sidewalk kind of setting. Cement treat the underlying soil and hopefully minimize the amount of frost heave and cracking that occurs later. So this is an opportunity I think that's still yet to be developed. Contractors working in that space I think could benefit. It's a great idea that you've shared. Please.
What ends up happening to the natural gas lines that get discovered? Like, how do you take care of the issue afterwards?
Oh, that's such a headache. In Utah, the natural gas lines are supposed to be buried at least 18 inches. And as you know, many of our pavement sections are thicker than that, and therefore in those spaces, the natural gas lines should be lower. The gas lines that we hit are usually the service lines. I have not yet been on a project where we hit a main line. The main lines are usually buried deep enough, but the service lines often come off the top of the pipe or off on one side, and they come up and then they go over and progress to the service location. And it's those connections or the transverse pipe itself that ends up getting clipped by the teeth on the reclaimer. Even when the contractor does a good job with what we call potholing in advance, like call the utility location service, let them put the different colored paints all over the road, yellow for natural gas, it's good to go dig it up before you start construction and just see how deep is it. Maybe some random sites and find out what you're up against. The repair involves a 911 call. It typically involves evacuation of everyone on the city block, door to door, knocking on the doors, barricading the street so no one else can come in. The emergency repair teams arrive. They often have their own backhoes, mini excavators, and all of the couplers needed to replace the section of pipe that was damaged. It's often a yellow colored polyethylene pipe. It tends to tear, and so they have to cut it, put in new couplers, put in a new piece, and hopefully bury it slightly deeper than they found it. That process can take from 2 to 3 hours for an entire day, depending on what's required for them to shut off active pressure on that natural gas line. So it's a big deal. I have personally recommended on some occasions the use of ground penetrating radar along some of these corridors to identify especially the depths of the utilities where we have known variability. And on those jobs, when the natural gas lines are close to the surface, the only remedy that we've used is having the reclaimer operator lift the drum as he passes over the line and then set the drum back down fully engaged at the appropriate depth for mixing, which means that some of the material wasn't, like, it didn't get the cement mixed to the full depth, but that's okay. Still way better than it was, and we didn't hit a gas line. So managing utilities is a big deal. I'll also note that managing trees is a big deal. Hopefully, most of the time we have a good connection with an arborist, but as we're bringing in tall construction equipment, we sometimes have beautiful trees along some of these residential and urban streets. We like to preserve those so we can hire an arborist to come through in advance and properly prune all of the trees so that when we bring in ready-mix concrete trucks and other trucks, we don't damage the trees. And while I'm thinking about it, I'll also note that as some of you end up in this space rebuilding roads, I always recommend high resolution camera work before you ever break ground. There are a number of times that we get later accused of causing damage to somebody's personal property, and it's often fraudulent. And if you don't have high resolution pictures to show that, no, that damage was there before we ever arrived, they might succeed in pulling the money out of your pocket. I can tell you a story about that if you want.
Sure.
You want the story?
Yeah.
Okay. On one occasion, I was on a residential job. We were building a new roadway, and a lady came out of the house with both hands above her head waving. Now that's a signal for an emergency. We don't do that if you're a trained construction worker unless there's an emergency. So I ran over to see what the emergency was. And she said, "Excuse me, sir." And I'm wearing my construction hat, my vest, right? I look like a construction worker. She said, "I had been feeling the compaction work. There's some vibrations that have been coming onto my property, and you owe me a new concrete driveway. Look," she said, "right in front of you. It's completely cracked from your work." I said, "Oh, I'm so sorry that your driveway is cracked. May I look at it carefully?" "Oh, yes," she said. "You go ahead and look at it, and then you build me a new one." So she stood there while I got down on my hands and knees to make a thorough inspection, right? There was grass growing in the dirt that had accumulated in the cracks of her driveway. So I stood up and I explained to her, "Oh, yes, I can see. You do have some cracks here, and they're growing grass. This grass has been growing for several months, and we only started just 2 or 3 days ago. I'm sorry, but we won't be able to provide you a new driveway." He looked at me and said, "Ah, shucks. I was hoping to get a new driveway."
That's good.
Nice try, right? Any other comments or questions? By the way, while you're thinking, I'll also note when I'm in the field with my students doing pavement research, I have found, especially in neighborhoods, I have to bring one more student than I actually need. And that student is the student who is the most talkative, engaging, gregarious student, because as soon as we show up with our construction vests and our equipment, people just start coming out of the house, right? And they want to know what you're doing and how long it's going to take. And if it's a grandma and a grandpa, they can tell you the stories that go with that road for the last 40 years. And if you don't have an extra person on the job to talk to them, you don't get your work done. So just a little tip for your future research.
Any other last round of questions? All right, if not, this was amazing. I really enjoyed the extent of the experience that you shared with us, Spencer. Really appreciate it. Thank you.
Well, thank you. I wish I could have been there in person, and I will make time perhaps in the next year to come visit.
Sounds good. Looking forward to it. And happy Thanksgiving.
Yeah, happy Thanksgiving to all of you. Thank you so much.
All right. See you next time. Take care.
Okay. Bye-bye. Good luck to everyone.
Thank you.